Problem number 31. We're given this vector field right here, x minus 1 cosine y plus 2x minus e to the y squared. We have the following picture here. So R is this region. It is a semicircle, semi-disk, I guess I should say, solid. C is the boundary. And note that C is oriented the opposite of how we usually want it to apply Green's theorem. So C is going clockwise here. So part A says use Green's theorem to evaluate the line integral over C of f dot dr. Well, that's going to be the negative. We throw in a minus sign because that's the wrong orientation of the integral over d of partial q partial x minus partial p partial y dA. So minus double integral partial q partial x is going to be 2 because there's no x dependence in those two. Partial p partial y is 0. Okay, so it's the integral of minus 2 dA, so that's negative 2 times the area of d. And the area of d, this is a semicircle. An overall circle would have area pi r squared. R is 1, pi times 1 squared is pi. So minus 2 times pi over 2 is negative pi. Okay, so that takes care of part A, the entire loop here. Let D, I guess I already used D for that. Oh, no, I guess R is. No. It's been a long day. Okay, there we go. Those all should be R's there. We are safe. D is just a part of the curve up here. How do we come up with that? There's no way I'm going to explicitly do that line integral. E to the y squared, that will be a mess. So instead we're going to do this line integral and then figure out how to put the pieces together to get that one. So the line integral around this bottom part here, so let me call this C1. Line integral along C1 of f dot dr. How do we parameterize this? R1 of t. So t would run from, we can go t comma 0. The y coordinate is always going to be 0. T, we want to go from right to left. So let's make it minus t. We make this minus t, then we can have t run from minus 1 to positive 1. When t is minus 1, we're at the point 1, 0, and t is positive 1, we're at minus 1, 0. So that will do the trick here. R1 prime of t will be negative 1, 0. We plug in R1 of t, x is negative t, y 0 up here. F of R1 of t is equal to x is negative t minus 1. Y is 0, so cosine y is 1 plus 2 times negative t there, minus e to the 0 squared minus 1. But when we do the dot product, f dot product r1 prime, this dot product this, we will end up with negative t minus 1 plus who cares, so, positive t plus 1, because that's minus 1 times that. So we're going to integrate t plus 1 as t runs from minus 1 to 1. So this will give us t squared over 2 plus t, plug in minus 1 to 1. And so this is 3/2 minus negative 1/2, and that's 2. So what do we conclude here? The line integral along this is 2. The overall line integral must be negative pi. So the line integral along the top part of the curve of f dot dr, what the instructions call d, has to be minus pi minus 2. Minus pi minus 2 plus 2 gives us minus pi.